So we are learning about models of the atom, Chemistry 11, Unit 1. So we know that long time ago, about 200 years ago, the first scientist's name was Dalton. Dalton's model. Introduced his model, he said that the atom is look like a sphere. Different atom, different sphere in the sizes and colors, and they are different. So because it's a sphere, he introduced his model as a sphere. We can call this solid sphere, or they call baseball model as well. It was good model at that time, because at least he recognized that this is a sphere. The atom is look like a sphere. After Dalton, another scientist that his name was Thomson's model. He introduced his model. He said that, atom is look like a sphere, as Dalton said, but at that time, they discovered the positive and negative charges. So he said the whole tire of this sphere is positive charge, and the negative charges embedded in this positive charge. That's why they call this plum pudding. Or always I say my student, it look like a watermelon. The all entire watermelon, the red parts are like a positive charge, and the seeds are electrons that embedded in this positive charge. The next model introduced by scientists, that his name was Rutherford. Rutherford's model. Rutherford said, atom is a sphere as made of the positive and negative charges, but positive charge are in the middle of the atom, that later we call this nucleus, and the negative charges embedded around this positive charge. These are negative charge. Later on in grade 12, you will learn that how Rutherford reached to this conclusion, how Rutherford discovered that the nucleus with the positive charge is in the middle and electron orbit around the nucleus. But in grade 12, just you understand till this, and that is enough. The next model introduced by Bohr. Bohr's model. Bohr a little bit complete Rutherford work and add a little bit to Rutherford model. That's why sometimes they say Rutherford-Bohr model, because they both complete each other work. So Bohr said Rutherford is totally right, that the positive charge are in the nucleus and in the middle of the atom. But negative charges or electrons cannot orbit anywhere that they want. They are orbited in a certain energy level around the nucleus. These are energy level or stationary state. And later on, again in grade 12, we expand this concept. We said that the distance between these energy levels, the energy is quantified. It means there are a certain amount of the energy between these two energy levels. So electron can orbit only on this energy level. Electrons cannot orbit between this energy level. No, only on this energy level. So the next model for an atom is quantum mechanical model. Quantum mechanical model that introduced by Schrödinger. But in grade 11, we are not focused on this model. In grade 11, we are focused on the Bohr model. Then in grade 12, we expand the quantum mechanical model. That's why I am focusing on the Bohr model in grade 11. That is really important. So, in Bohr model, when you want to learn about the Bohr model, the first is that the drawing electron configuration based on the Bohr model, right? They will ask you drawing electron configuration based on the Bohr model. Based on the Bohr model. So, for example, you know that periodic table, we have 8 columns and 7 rows. You learn in grade 10. So, for example, we want to draw the Bohr model for lithium. Lithium is 3 and 7. So, first of all, you know that for lithium, this is chemical symbol. And you know this is atomic number, right? Atomic number that we show with Z as is represent number of proton. That always I show like this, P. And this one is atomic mass. Atomic mass. We show with the A, and it represents number of proton plus neutron. So, you learn in grade 10, then for an atom, for example, like lithium, you are able to write down all subparticles of the lithium. So you understood that Z, this atomic number is 3. A means atomic mass is 7. So it means number of proton is 3. Number of a neutron, of course, because this is proton plus neutron, and this is only number of proton. So number of neutron is A minus Z, right? A minus Z. It means 7 minus 3 is 4. What about number of electron? So you know that because the lithium is neutral, it means there is no any charge on top of the lithium here. So it means the number of proton that is plus and number of electron that is negative should be same. So in any neutral atom, the number of proton and number of electron are same because number of proton is positive charge. It should be same of number of electron that is negative charge. So now when you want to draw the electron configuration based on the Bohr model, it means you have to put electron around the nucleus. So you have to put in the nucleus, so we have proton and neutron, right? So we have to put 3 proton and 4 neutron in the nucleus. Then electron incoming in the energy level. So you will learn that in Bohr model, the first energy level, always maximum electron in the first energy level is 2 electron. So because lithium has 3, so 1 more left. So this is the Bohr model for the lithium. So for any element, when you are drawing the Bohr model, this energy level, we call this outer shell energy level, or we call this valence shell. Valence shell. Also, electron in this shell, we call this valence electron. So valence electron for lithium is 1. Another things that I would like that you pay attention is when you are drawing the energy level, the first energy level N is 1, the second N is 2. This lowercase n shows the energy level and is exactly same in periodic table with the number of the period or row, because the first period N is 1 has 2 elements. That's why maximum can get 2 electrons. The second row, N2, has maximum 8 elements. So that's why can accept maximum 8 electrons. I will show you later in the periodic table. You can understand better. You have to connect between this N energy level and the number of the period or number of the row in periodic table. So the fact that now you have to focus on this is 2 hints that is really important for us. Let me write down with the blue. So the first hint is when we are putting electrons in energy level, or when we draw the electron configuration based on the Bohr model, energy level. So the first energy level always gets 2 electrons, right? This is N is equal 1, N is equal 2, 3, and N is equal 4. The first energy level always 2 electrons, the rest of them 8, 8, 8. This is the Bohr model. But if the question asks us if we want to know, this is another hint, but if we want to know the maximum electrons in each energy level, we have to use this formula, 2n2. So how would we calculate this? So if n is 1, it means the first energy level, the maximum electrons is 2 times 1 power 2 is 2 electrons. N is 2, maximum electrons is 2 power 4 times 2, 8 electrons. N is 3, maximum electrons is 18 electrons. And N is 4, maximum electrons is 4 power 2 is 16 times 2, 32 electrons. So, although we are writing 888, but the maximum electrons here is 2 electron, here is 8 electron, here is 18 electron, and here is 32 electrons. So Bohr model cannot explain why, but next year in grade 12 with quantum mechanical model you can understand, because on that model we are introducing the sub-level, and then you can see how exactly the third energy level can accept 18 electron. But in Bohr model we cannot put 18 in the third energy level, we have to put 888. This is some limitation of Bohr model that we will solve it next year with the quantum mechanical model. So after understanding these hints, we are practicing in this session on few drawing the Bohr model. So for example, sodium is 11, 23. So usually I'm drawing like a curve. I don't draw circle, and I'm asking my student, they can draw like a curve. That's enough. So this is 1, 2, 3. So for sodium, N is 1, 2 electron, N is 2, 8 electrons, so far 10. Because sodium is neutral, there is no any positive or negative charge. If this atomic number is 11, that atomic number represents number of proton or positive charge. So we have 11 electron as well, right? 2, 8, and 2 and 8, 10, so 1 electron. So for sodium as well, this is valence electron, valence shell, and this electron is valence electron. Let's draw the Bohr model for magnesium, that is 12, 24. So again, 1, 2, and 3. So N is equal 1, N is equal 2, N is equal 3. So the first energy level 2 electron, the second 8 electron, 10 and 2 electron. So this is valence shell, and this is valence electrons. I would like that you pay attention. You will see that the sodium is in the group 1, magnesium in group 2, right? If you draw the Bohr model, let's draw the Bohr model for aluminum 2, then you will reach the good conclusion and connect this to the periodic table. Aluminum 13 and 27. So 2, 3. So is N is equal 1, N is equal 2, and N is equal 3. So it's 2 electron, 8 electron, 3 electron. So again, for aluminum, this is valence electrons and valence shell. So you will see that the sodium is in the group 1, 1 electron, 1 valence electron. Magnesium group 2, 2 valence electron. And aluminum group 3, 3 valence electron. So the number of the group in periodic table is equal the valence electron. Number of each group in periodic table is equal to number of valence electrons. You have to be able to make a connection each concept with periodic table. Unit 1 of the chemistry 11 is fundamental for chemistry because you are learning a lot about the periodic table. So that's why I would like to draw the periodic table here. So if it's group 1, this is group 2, this is transition metal here, then group 3 or 13, 4 or 14, 5, 6, 7, and 8. I said 3, 4, 5 because it's easier than if you want to say 13, 14. It's easier for understanding. I know in your book they put 13 and 14 and so on. So group 1, group 2, group 3, group 4, group 5, group 6, group 7, and group 8. I put with Romanic number because you need to know this Romanic number too. So group 1, we reach to the conclusion, group 1, all elements in group 1, they have valence electron 1, valence electron 2, right? Valence electron 3, 4, 6, 7, and 8. So it's really important that you connect the valence electron. It means the number of electron in the outer shell energy level or in valence energy level with the number of the group in periodic table. Later on, as we continue, it's really helpful for us. So I want to continue after this concept to learn about valence, about